Hey, welcome back. We're just continuing on our factoring review worksheet here. Now this section is where it gets a little bit more tricky than just the basic factoring. So we're going to have to add a few methods here that I'm going to show you. The first one here, number 13, the reason why this is different from the other ones, I don't know if you heard that, but that was the school bell. I'm still at school. Bells are still going. Anyway, the reason why this one is different is because we now have a number in front of the squared term, right? This is n squared. We have a number in front. The ones we've done before, they were kind of nice. This was just k squared or x squared or x squared or n squared. And there wasn't really a number out there. There actually is an invisible, 1. This is 1x squared, right? But these ones actually have numbers out in front. So these are going to be a little bit different. There's a different method for doing it, but some of the patterns that we saw still apply. So in this one, let's read the instructions first, make sure we know what we're doing. It says factor each expression completely by first factoring out the greatest common factor and then factoring the trinomial. So we got a 5 here, and what it's saying is there is a greatest common factor in here that we can pull out. So if that's the case, we might be able to just factor this, pretty easily. So let's take a look and see what the greatest factor might be. Well, these don't all have n's. This has an n, this has an n squared, but this doesn't have any n's in it. This one has a 5, this one has a 15, this is a 350 or a negative 350. So they all have 5 in it. So when I'm looking for the greatest common factor, this is very similar to what we did earlier in the assignment in problems 3 through 6, where we found that greatest common factor and factored it out. That's what we're going to do here. The greatest common factor here is a 5. So if we pull out that 5 or factor out that 5, we've got to figure out what's going to be left over. Now with a 3-term expression, we're going to have 3 terms left over in our parentheses. So if we factor out a 5, this should be an n squared, this should be a plus 3n, and then this guy right here is going to be a minus 70. Okay, let's just double check to make sure we actually factored it right. So if we can distribute that 5 and get the same thing we started with, we should be good. So 5 times n squared is 5n squared. Okay, check. 5 times 3n is 15n. Okay, check. And then 5 times negative 70. Well, 5 times negative 7 is negative 35. So 5 times negative 70 should be our negative 350. So that looks like it checks out. Okay. Now from here, what we're going to do is we're going to factor this trinomial, right? And that's going to be similar to what we did before. So if we had an n squared plus 3n minus 70, now we still have the 5 here out front. We don't want to forget that. Okay, but right now we're just going to focus on factoring this guy. So we know it's going to look something like this. Again, that's kind of coming from experience with foiling. We know we need to have an n and an n here because when we FOIL, n times n will give us n squared. Okay, the numbers that go back here are going to have to multiply to a negative 70, and they have to combine to a 3. Okay, so we got to think of things that multiply to negative 70 but combine to 3, and that means they're going to be pretty close. The obvious choices might be 7 and 10, so it's because 7 times 10. You could also do 32 and 35 and 2. Those will multiply to 70. I think the 10 and 7 are going to work out really well. Now notice this is a negative 70, so that means whatever multiplies has to multiply to negative 70. So let's just try a negative 7 and a 10. Okay, so negative 7 times 10 is negative 70. Okay, awesome, that sounds good. Negative 7 plus 10, or combine negative 7 with 10, we're going to get a positive 3. Okay, so those are the numbers that we need. We need a minus 7 and we need a plus 10. Okay. Now if we wanted to double check, we could by foiling like we did earlier. I'm not going to do that in these problems here because there's already another step, but if we wanted to, we go n times n is n squared, right? N times 10 is 10n, plus the negative 7n we get is going to give us our positive 3n, and then negative 7 times 10 will give us our negative 70. So without like writing all the foiling out, it looks like it checks out. Now this 5 we factored out still needs to come down here along for the ride because we factored that out as well, and this is going to be our final answer. So that's not too difficult. It's basically what we did in the previous problems, in problems 9 through 12 here. We just have to pull out that common factor first, and that's something you always want to look for. You always want to look for, see if they have a common factor, factor it out if they can. That's going to make your life a whole lot easier. Okay, so let's go down to the next problem here, number 14. And let's see what we can figure out here. Now again, we kind of already know these are going to have a greatest common factor just because it tells us that there is a greatest common factor. So we know that that's the case. In this case, we have a -3 here, a 48, and a -189. And it looks like 3 is going to go into all of them. We don't have an x in all 3 places, right? So we can't take out an x, but we can take out a 3. In fact, what we probably want to do is we want to take out a -3 because we want to have an x squared kind of by itself. When we're done factoring out the greatest common factor, we want our trinomial to start with n squared or x squared or k squared, right? We want it to look like something like this. So we're actually going to factor out a -3. Okay. When we factor out that -3, we're going to have 3 terms left in our parentheses because we have 3 terms to start with. Factoring out a -3 from here, I'm going to have an x squared. Here I'm going to have a, let's see, 3 times, I think that's 16. I'm going to double check that really quick. Yeah. So we're going to have a -16x. And then what I'm doing is I'm just dividing by 3, or -3. So 189, -189 divided by -3 is 63. Okay, so it looks like this is going to be a plus 63. All right. Now I use my calculator to help me with that. What I actually did was I did 48 divided by -3, -189 divided by -3 to see what's going to go in there. But to double check, when I distribute this, if I were to distribute that -3, I should get back where I started. So -3 times x squared is -3x squared, check. -3 times -16, that's going to give me a positive 48, and then there was an x there, so 48x, that checks out. And then this -3 times this positive 63 will give me my -189. So that looks like we're on the right track there. So this -3 is one of our factors. But now we're going to focus on this trinomial, right? This x squared minus 16x plus 63. The -3 will come along for the ride, and that'll be in our final answer. But right now we're trying to factor this piece. And we know that it's going to look something like this, just from experience foiling. We know that that's how we get these trinomials. We're going to have x and x up front because x times x is x squared. Okay. And then we have to figure out what 2 numbers we need. So again, they have to multiply to this guy, the 63, and they have to combine to give me a -16. So we might have to do a little bit of division here. The only things that I know that combine to give me, or multiply to a 63 is 9 and 7. I know 63 is 9 times 7. So I'm going to do a 9 and a 7 here. Okay, now 7 times 9 is 63, and that's great, but 7 plus 9 is 16. Right, if I combine a 7 and a 9, I get a positive 16, which is not what I want. I want a -16. So the only way I can get a -16 with combining and a positive 63 with multiplying is that I have to make these both negative. Right, -7 times -9 will give me a positive 63, and will combine to a -16. So those are the numbers that I need inside my parentheses. -7, -16, okay? So that's how this trinomial factors, but don't forget that we started out with a negative number out there, a -3, okay? So our final answer will have the -3 multiplying those 2 other factors, okay? All right, now these ones, like 13 and 14, also have a number in front of the squared term. So our first instinct might be, okay, great, let's factor out the 5. So you're like, cool, let's factor out a 5. Well, 5 doesn't go into 14, and it doesn't go into 9 either. And so we have to have another method. We have to figure out what we're going to do here, right? Now this problem asks us to do it by grouping or by guess and check. Okay, so I'm going to show you one of each, just so you can kind of get some experience with both, and then you can kind of pick which one you like. The guess and check method can sometimes be fast, but it can take a long time if there's a lot of different possibilities. So let's kind of see how that's going to look. Now, again, I can't factor out that 5, so I only have a couple options. I know that this when it factors, this trinomial has to factor to something like this, and I have to think what 2 things can go up here in the front. Now, whatever the first 2 terms are, they have to multiply to give me this guy, right? So I'm going to have two x's just like I did before, x and x, but instead of just a plain x here, I'm going to have something that multiplies to 5x squared. So I'm going to have a 5x and an x here. That's how I'm going to get my 5x squared. So instead of just a regular x and a regular x like we had here, right, x and x, I have to have a 5 there. It's the only way I can really get a 5x squared. Okay, now in the back I have a 9, right? And so these two numbers, they also have to multiply to 9. Now the thing that's weird is they're actually not going to combine to give me 14 on their own because that 5 is going to multiply them. For example, if you're trying to think of two things that multiply to give you 9 but combine to give you a 14, you're not going to be able to find it. In other words, if I have a 9 here and 14 here, I'm thinking, okay, well 3 and 3. Well, those don't combine to be 14, so that doesn't work. I can try 1 and 9, because 1 times 9 is 9, but those don't combine to 14 either. And I've kind of exhausted all my possibilities. So there aren't actually two numbers that multiply to 9 and combine to 14. And the reason why is because if you think about the whole process of FOILing here, whatever this number is right here is also going to get multiplied by that 5. So it's a little bit different than we saw before. So what we do know, though, is that these two numbers, whatever they are, they do have to multiply to 9. So what we can do is we can try guessing and checking. We can just try all the combinations available to us to make sure that we get the right thing. Okay, so let's just try two things that multiply to 9, right? I don't even know what's going to happen with the middle term. We're just going to try some stuff. So I'm going to put a +1 and a +9 right here. Okay, what I know is that right here, I'm going to get 5x times x is 5x squared, and I know that if I do the last terms, 1 times 9, that gives me a 9. So I know that these terms are covered. I'm going to get those terms that I want. I just don't know what the middle term is going to be yet. So in order to figure that out, we're going to actually FOIL to see what happens. So 5x times x is the 5x squared. Okay, I knew that was going to happen. 5x times 9, well, 5 times 9 is 45, so this is 45x. 1 times x is just 1x or x, and then 1 times 9 is 9. So you can see that I got the right first term and the right last term, but these two middle guys are going to combine to give me a 46x, and I'm trying to get a 14x. Okay? So I know that this isn't the right way to do it. I tried a possibility, and it didn't work. So we're going to have to go back to the drawing board. Okay? That's why this is called the guess and check. Okay? So let's try something else. Another thing I can use to give me that 9 in the back is a +3 and a +3, right? Because 3 times 3 is 9. Okay, if I do the 5x times x, I get that 5x squared. So this setup here guarantees I'm going to get my 5x squared and my 9. We just have to see if we're going to get the right middle term now. So let's FOIL and double check and see what we get. Okay, so 5x times x is the 5x squared. Okay, I knew that was going to happen. That's no big deal. 5x times 3 is going to give me the 15x. Or give me a 15x, excuse me. 3 times x is going to give me 3x, and then 3 times 3 is going to give me 9, right? These two middle terms are going to combine to give me 18x, and I wanted a 14x. Notice, I have the first term correct. I have the last term correct. I just didn't get the right middle term. I got an 18 instead of a 14. Okay, so I got to go back to the drawing board again, and I got to try something else. Okay. So let's try the 9 and the 1 again, but let's put them in a different spot. So let's put the 1 here and the 9 here. Now that should still give me a 5x squared up front and it still give me a 9 up in the back, but let's see what happens in the middle. So 5x times 5x is 5x squared, okay? 5x times 1 is 5x, so we're just FOILing here. 9 times x is 9x. Okay, and then 9 times 1 is 9. So just doing our FOIL. We got the first term right. We got the last term right. We already knew that was going to happen. But check this out. 5x plus 9x. Well, hot dog, that's 14x, right? So, okay, cool, we got it. This is the right thing because this will combine to give me my 14x. Right? This is my 5x squared plus 14x plus 9. So this is the right form, right? We had to try a few different options. We tried to use process of elimination. We figured the only two things that can go here to give me a 5x squared, and the only two things here that give me a 9, or we try all those possibilities rather, and we figure out which is the one that's going to give me the right middle term. Okay, so that's a guess and check method. Now there are other methods to solve this. The one I showed you is grouping. I'll do that on the next problem set here, but I just kind of wanted to give you some experience with this guess and check method, just so you can kind of use it if you like it. I think sometimes multiplying these out multiple times or guessing and checking helps you to kind of see what's happening. So for some of you guys, this might be your preferred method, but grouping is still a very powerful method because you don't have to guess and check. It's just kind of a straightforward way of getting there. So let's try this guy. Let's do number 16 here. And again, let's use the guess and check method. Okay. So I see a 2 up there, right, in my trinomial here, and I'm thinking maybe I can factor that out. Well, 2 doesn't go into 15 or 27, so I'm kind of stuck there. Can't factor anything out here. There's no greatest common factor like there was here in 13 and 14. We're going to have to use a different method here. So we're going to do guess and check. So we'll put our 2 sets of parentheses down here, and we got to have something that multiplies to 2r, and we have to have an r in either place. So I got to have an r here. The only option I really have to get 2r squared is a 2r and an r. Right? If it's an r and an r, that will give me just 1r squared. We want a 2r squared. So this is the only option to give me that guy. Right. Now we need some options that will give us the negative 27. And we can just try a few different ones. We can just kind of mess around with that. So let's try a negative 3 and a positive 9. Let's see if that works, because 9 times negative 3 is negative 27, right? So maybe this is the combination we need. The only way to really find out for sure is to FOIL and see what's going to happen. So let's FOIL. This is just a check. 2r times r, right? First terms. Well, there's my 2r squared, okay? Let's do the outside. 2r times negative 3, that's minus 6r, okay? 9 times r, that's going to be plus 9r. And then the last term's 9 times negative 3 is negative 27. So I got the last term correct, and I got the first term correct. I knew that was going to happen. Did I get the middle term correct? Well, I want a negative 15, and these are going to combine to give me a positive 3r, which is not going to work. So that's not the right combination. We need to change the order, maybe need to change the signs. So let's see if we can fix that. Now, there's lots of different combinations, because here we knew they were both going to be positive, but here we need a positive number and a negative number to multiply to give me this negative 27. So there's actually a lot of possibilities that we can try. We can try, a negative 9 and a positive 3. We can try a negative 3 here and a positive 9 here, or we could try a positive 3 here and a negative 9 here. So with the 9 and a 3 and a positive and a negative, there's actually 4 different combinations we can try, and that's not even counting, like, we could even try 1 and 27 or negative 1 and negative 27 or whatever. So this guess and check, it can take a little bit of time, but the more you do it, the better you'll get at it. So I think what we're going to need here, just by kind of looking at this, I think we're going to need a minus 9 here and a plus 3 here. Okay, just kind of looking ahead. Let's see if I was right. This is kind of my guess. 2r times r is my 2r squared. Okay, awesome. 2r times negative 9 is negative 18r. Okay. Positive 3 times r is 3r. And then 3 times negative 9 is going to be negative 27. So again, I know I got my last term correct, and I know I got my first term correct. I already knew that was going to happen because I picked the stuff to be there. I picked the pieces that I need to get that right. Now I just got to make sure the middle term is correct. If I combine a negative 18r and a positive 3, what does that give me? Negative 15r. Awesome, so that's what I wanted. This is going to give me 2r squared minus 15r minus 27. Awesome, that's what I wanted. So this isn't my answer, this is just my check. This is my answer, this is the right thing. I picked the right numbers to go in here to actually figure out what I needed. Okay, so that's factoring by guess and check. You basically just, you eliminate, or you pick the only options that you have for your terms, and you try all the different combinations that are going to give you the first and last terms, and then you just make sure that you get the right middle term. So some people like that method. I kind of prefer a more straightforward method, which is why I showed you factoring by grouping, but you can also do it this way. Okay, this is going to be kind of the longer section of the video just because this is the most intense factoring method that we're going to see. After this, it's actually going to go back and get a little bit easier in the process here. If you're already good with factoring by grouping, that's great. You can go try these on your own. You could do a guess and check method here as well. But I just wanted to kind of run through factoring by grouping with you. So this one right here, let's kind of talk about what potential problems we could have with this guy. Now, first of all, we want to see if there's a greatest common factor. There's not, because this doesn't have any x's, and 3 doesn't go into 4, and I can't factor out a 4 from a 3, so I'm just going to have to do something else. Now, I could guess and check with this guy, but let's think about how many different possibilities there would be. So for a 4x squared, I know I need an x and an x, but this could be like a 4x and an x, but it could also be a 2x and a 2x. Right? I'm not sure which one it is. I know I need to multiply to get to 4x squared, but it could be either of these options. To get a negative 10 back here, I could do negative 1 and 10, or 1 and negative 10, or 2 and negative 5, or 5 and negative 2. And I have to try these in each of these scenarios here to make sure I get the right thing. So there's potentially like 8 different combinations of things that I could get here. 8 different possibilities that I'll have to try before I made sure I got the right thing. Sorry, my lights went out. So you could get lucky and you could factor by guess and check on like the first try, but you could also be sitting here for a really long time trying to get the right combinations of things. So for something like this where there's multiple options for combining or multiplying to get the first term, and there's multiple options for multiplying to get the second term, there can be lots of different possibilities to go through, and that can be time consuming. So the next step I'm going to show you here is factoring by grouping. Now, if you've been in my class this semester, you've seen this before. So this should be a review, but it's a little tricky. So let me show you how it works. Okay, the first thing we need is we need to get what we call our grouping number. And so if you remember in standard form, or now what we're calling quadratic form, this is kind of that form ax squared plus bx plus c. So what I want to do is I want to multiply the a times the c to get my grouping number. So I'm going to go grouping number equals ac. So gn for grouping number. That's a times c, which is going to be negative 40 in this case. Okay, so that's the magic number we're working with. Now what I'm going to do is I'm going to do one of these x things again, and I'm going to put negative 40 up here, and then I'm going to put a negative 3 down here. So this is really, really similar to what I did in some previous problems, but we're not going to actually use those numbers as the numbers that go in our factors. I'll show you what's going to happen with them. What we're doing, though, right now, this is similar. We're looking for 2 numbers that multiply to negative 40 and combine to a negative 3. Okay, so if they're multiplying to a negative 40, we know one's positive and one's negative. We just got to find out that magic combination. So we can try like a negative 10 and a 4, right? Those multiply to negative 40. Negative 10 times 4 is negative 40. But if I combine those, I get a negative 6, and that's not what I'm after down here. Okay? So let's back it up a little bit. What else could we do? Well, we could do 5 and 8, right? 5 times 8 is 40. Let's try a negative 8 and a positive 5. I think that will work. So negative 8 times positive 5 is that negative 40. Okay, great. If I combine them, do I get a negative 3? I sure do. Right, now, in the past, what we would have done here is we would have taken these two numbers, and those numbers would have been in our final answer. We would have done something like this. X minus 8, x plus 5, and we would have been done. But this is a little bit different because of that guy right there, right? That 4 right there is making a difference. We can't just throw those two numbers in with an x and an x because we're supposed to have a 4 up there, okay? So those numbers are still important. We still need them. We just got to do something different with them. Also notice that the number that went here was not negative 10. When this was just a regular old 1, like back in the previous problems, we didn't have like a 4 up here, we would have just put the negative 10 in here. But this time we put the grouping number up there. So it's similar, but there's a few different things that are happening here. We still use this, we can still use this kind of X thing to find the two magic numbers we're looking for. Now in this case, what we're going to do is we're going to take this middle term and we're going to split it into these two numbers, right? We know these two numbers combine to give me a negative 3. Great, so let's just uncombine them. So what we're going to have is we're going to have the 4x squared. Okay, that didn't change. That's still right here. Okay, that 4x squared is now right here. We're still going to have the minus 10 in the back, right? That hasn't changed either. So I still have this term and this term. The middle term, what I'm going to do is I'm going to write this negative 3x using these two numbers. So I'm going to write negative 8x, and then I'm going to also do a plus 5x. Okay, so I'm using these two numbers right here to go right here. If I combine negative 8 and negative 8x and positive 5x, I'd get that 3x. So this statement and this statement are equivalent. I haven't really violated any rules. I just kind of uncombined like terms here. Okay, so where does that get us? Well, if you do that and you get the two numbers correctly, you'll be able to find a common factor with these and a common factor with these. And it actually doesn't matter which order you put it in. If I put the 5x here and the minus 8x here, that would be fine too. As long as the 8's the negative one and the 5's the positive one, it doesn't matter the order there. It might be easier one way, but you're still gonna get the right answer. Okay. So next what we're going to do is this is the factoring by grouping part. This is where we actually group. We're going to take these two and call this a group. These two terms. We're going to factor out what we call the greatest common factor, like we did before, from these two terms. So what do they have in common? What factors do they have in common? Okay, so these both have a 4x in them. This guy has an x, this guy has an x. 4 goes into 4, 4 goes into 8. So we're going to factor out the biggest thing possible, which in this case is a 4x. So just those two terms. We're completely ignoring these two terms for just a second. We're just factoring these two terms just like we did in problem like 3, 4, 5, and 6. So what needs to go here? Well, if I'm factoring two terms, I'm going to have two terms left in the parentheses. So I need 4x times something that's going to give me 4x squared. 4x times what gives me 4x squared? This has to be an x, because 4x times x gives me x squared. Okay, in the back here, 4x times what is going to give me this negative 8x? Got to be a negative 2, right? 4 times negative 2 is negative 8, so 4x times negative 2 is negative 8x. So that's our first piece. Now we're going to look at the second two terms, the second group basically, and we're going to see what factor they have in common. Well, they don't have an x, right? Like this one doesn't have an x. This one does. But they do both have a 5 that goes into them. So I'm going to put a plus. Don't forget that plus. Okay, plus. This plus needs to come down here. 5. And then when we factor out, we're going to get x minus 2. All right, just to double check. 5 times x is 5x. Check. 5 times negative 2 is negative 10. Check. Okay, cool. Now, if you do that right, and if you pick the right numbers here and here, the correct numbers, then you'll notice that these actually now have a common factor. This chunk here and this chunk here, they both have the x minus 2 in common. And so we're going to say, well, now this is a common factor, the x minus 2. So we're going to factor out the x minus 2 from both terms, and whatever's left over, like just imagine pulling these two terms out, right? These are going to go, or like cover them up. What's left over? 4x plus 5, right? So once you pull this out, what you're going to have is 4x plus 5, the 4x and the 5. And that's how you factor by grouping. Now we could also write 4x plus 5 times x minus 2. That's fine too, because multiplication, these guys, these two factors are getting multiplied. And since multiplying is commutative, the order doesn't really matter. So either one of those would be okay. And that's factoring by grouping. Okay, let's do it a couple more times, and we'll see how you did. If you want to try these first, go for it, and then you can come back and watch the video. I'll show you this next one here, and we'll see where we're at from there. Okay, the first thing we need to do, remember, is to find a grouping number. Actually, we should probably check to see if there's not a common factor, right? Because there's a 4 and there's a 4 and there's an x and there's an x. But there's not something that they all three have in common. So we can't really do anything there. So what we're going to do is we're going to find our grouping number, right? So a times c. 4 times negative 4 is our grouping number. That's negative 16. Okay, we'll put that at the top of our little x here. That's just to keep track of the numbers here. Now, you don't have to do it that way, but that's pretty common. The other thing we want to do is make them combine to negative 15. Okay, so two numbers that multiply to negative 16 but combine to be negative 15. Okay, well, this one's not too bad. I think we can figure this one out. I think it's going to be a negative 16 and a positive 1. All right, negative 16 times 1 is negative 16. Negative 16 plus 1 is negative 15. So those are the magic numbers. Now remember, we can't just take those numbers and throw them in with x like we did before on the previous page. We'd love to be able to just be like, oh, x minus 16 and x plus 1, and we're done. But that's not going to give us the 4x squared that we wanted, so that's not going to work. Also, notice the reason why this is a little bit different from problems that we've done in the past is in the previous problems, when we didn't have a 4 there, or when we didn't have a number in front of that x squared, all we did is just put this number and slapped it right there. Normally, this would have been a negative 4. But with a number out in front, you got to multiply that guy through. Okay, so this is the setup. This is the numbers that we're going to get. So we're going to have 4x squared, right? That hasn't changed. That 4x squared is just coming from this guy's coming from this guy. We're still going to have a minus 4, right? That guy. We're just going to change what this middle piece is. We're going to split it up into two pieces. So instead of a negative 15x, we're going to write negative 16x and 1x, right? X or 1x. Okay, so that's kind of the setup there. Now again, if I switch the order of these, it would still work. If I had an x here and a negative 16 here, it would still work out. At the end, the factors would be in the opposite order, but again, that doesn't matter because multiplication is commutative. As long as the x is the positive one and the negative 16x, or the 16x is the negative one, it's going to work out. So let's factor by grouping. What do these guys have in common? What's the biggest thing they have in common? Well, they obviously both have a 2 that goes into them. Okay, but they also both have 4 that goes into them. So we want to pick the greatest common factor. Okay, so we got 4. They also both have an x in them, right? So 4x is the common factor. And when I factor that out, I'm going to get x minus 4. Double check. 4x times x is 4x squared. Cool. 4x times negative 4 is negative 16x. Awesome. Okay, now these guys, when you look at them, it doesn't seem like they have a lot in common right now, right? It's an x and a negative 4. So if that's the case, okay, let's just factor out a 1 then, right? That doesn't usually help us, but in this case, notice I have an x minus 4 already, and there's an x minus 4. So I could say this is 1 times x minus 4, right? That would still work. 1 times x is x. 1 times negative 4 is negative 4. But now I have this setup that I need. So I kind of need that number out there. Even if it's a 1, that's okay, I need it. Now notice that with this chunk and this chunk separated by the plus, they have a common factor. They both have an x minus 4 in them. And so I can basically cover that up, right? And I get 4x plus 1. But I'm going to factor those two guys out. So I have x minus 4. And when I do that, when I pull that x minus 4 out, I'm going to have 4x plus 1 left over. Okay, now again, I can switch the order if I wanted to, and if I had these in the opposite order, it would come out the other way. So if you wanted to, you could switch the order of these. Either one of these would be correct. Okay, and there you go. Okay, factoring by grouping. All right, if you haven't done any on your own, try these next two. Stop the video, pause it, try them. Okay, see what you get, and then come back and check. So do that right now. Okay, you should be coming back from pause. Now we're going to run through these really quickly. So let's find our grouping number. 7 times negative 2 is negative 14. And I want a negative 5 down here, right, the middle term. So I need two numbers that combine to negative 14, combine to negative 5 and multiply to negative 14. That sounds to me like it's going to be a negative 7 and a 2. Just double check. Negative 7 times 2 is negative 14. Awesome. Negative 7 plus 2 is negative 5. Awesome. Okay. So there's still a little bit of reasoning here. There's still a little bit of guess and check, kind of, but you can kind of like minimize how much guess and check there is by just looking at just the numbers on their own, and that's kind of helpful. Okay, let's break this bad boy up. So we got 7r squared, and we got a minus 2, right? The 7r squared is coming down, the negative 2 is coming down. In the middle, instead of negative 5r, we're going to do a minus 7r and then a plus 2r. Right? Those numbers are coming from those guys right there. So negative 7, positive 2. Factor by grouping. They both have 7r in common, and that leaves us with r minus 1. These guys both have a 2 in common. When we factor that out, we get a r minus 1, and we're expecting to get the same thing in parentheses here. If you don't, that means either it doesn't factor or you did something wrong. So you got to go back and backtrack if these parentheses pieces don't match. They need to match. Okay, so now we factor out the r minus 1, right? If you pull that out, you're going to have 7r plus 2 left over. So up front, r minus 1, and then you factor out a 7, or you factor out the r minus 1. What you have left is the 7r and the plus 2. Cool. Pretty quick. All right, let's look at 20, and then we'll stop the video, and we'll do the rest of them in another video. Okay, here we go. So 3 times negative 21 is negative 63. That's my grouping number. Okay, you don't have to do the little x here, but I kind of like it. I've seen some people do it in the past. I've seen this demonstrated in the past, and some of my students I see do it. It's kind of nice to just keep track of stuff. Okay, we're looking for two numbers that multiply to negative 63 and combine to give me a positive 2. That looks like it's going to be negative 7 and 9. So multiply these, get negative 63, combine them, get 2. Okay, so I'm going to have 3v squared minus 21. So the first term and the last term are still the same. The middle term is the one that splits. Okay, so instead of 2v, I'm going to write negative 7v. And then I'm going to, over here, write plus 9v. Okay, now you might be thinking to yourself at this point, hold on, Mr. Lowry, put the 9v over here so that it has a 3 in common, and put the negative 7 over here so it has the negative 7 in common. You can totally do that, and that will totally work. What I want to demonstrate here, though, is that it doesn't really matter the order that you put them in. It's still going to work out. Okay. So if this was the case, we'd have to go from here. Let's just make sure this works. Even though it kind of makes sense to put the plus 9 over here and the minus 3 over here, or the minus 7 over here, we're going to make this work anyway. So what do these have in common? Pretty much just a v. Okay, so v times 3v minus 7. Okay, the number doesn't come out. That's okay. Okay, what do these two guys have in common? Well, they have a 3 in them. They both have 3 that goes into them. So if I factor out a 3, I'm going to have 3v minus 7. Okay, well, that's awesome, because now I have matching parenthesis terms. So if I were to factor these guys out, I'd just be left over with a v plus 3. So let's pull out the 3v minus 7, and what's left is v plus 3. Still works. Now, again, if you had the plus 9 here and the minus 7 here, that's fine. It's going to work out maybe even a little bit easier, but either way, it's going to come out to be the same thing. The only difference is that the two factors will be flipped, but that's okay. So that was kind of a long video, but this is kind of an intensive process, or a time-intensive process. And we also went through quite a few problems. So hopefully that helps you with factoring by grouping. If you are still confused on factoring by grouping, hopefully that's going to straighten things out for you a little bit. Of course, there's other scenarios that you could potentially see, but I like factoring by grouping because it eliminates the guess and check. I don't have as much guesswork. It's more straightforward. So pick your method. Some of these would be pretty hard to do by guess and check, but I'll leave that up to you. And check back in the next video if you need some help on the next problem set. Thanks.